In this video, we will be revisiting contribution margin, break-even, and degree of operating leverage, but this time, instead of using a single product, we will use multiple products. Here is our scenario. So we have a product A and a product B. Product A has the sales revenue you see on the screen, less variable costs, equals contribution margin, and we have a total units sold for each product and a total fixed costs for the company. So here, because we have multiple products, we will be calculating a weighted average unit contribution margin and a weighted average contribution margin ratio. So our contribution margin is taken from the data that was given to us. And then we take the units that were given to us and we get a contribution margin per unit. So for the product A, we have a contribution margin of 27,800 divided by 1,000 units gives us 2780, which is the contribution margin per unit. Now, each of these products, they're added together, so the contribution margin for both products is the $57,200. Total units, 1,000 plus 2,000 equals 3,000. So the $57,200 divided by 3,000 gives you a contribution margin per unit for all products of 19.07. You can also calculate this a second way. For example, in the scenario, we have been given 1,000 units for product A and 2,000 units for product B. The total units are 3,000 units. So if we take the product units for product A of 1,000 and divide by the total units of 3,000, we get 33.3%. Same calculation for product B. Now what you do is take 33.3% of that 27.80 contribution margin per unit for product A, and you get 9.27. And if you take 66.7% of the 1470 for product B, you'll get 980. If you add those two together, you also get 19.07. So that is our weighted average unit contribution margin. Now let's look at weighted average contribution margin ratio. We have our sales revenue, variable costs, and contribution margin that have been given to us in the problem itself. In order to do the contribution margin ratio for product A, this is the same calculation for product B. You take the contribution margin, so for product A, that'll be $27,800, and divide by the sales revenue of $40,000. That gives you a contribution margin ratio of 69.5%. For product B, it gives you 58.8%, and for the total of the two products, we get 63.56%. That's the number that we're looking for. However, you can do this in another way, where you take that contribution margin ratio and you multiply it by the sales revenue mix. And we get the sales revenue mix by looking at product A. The 40,000 is what percent of the total 90,000. So that 40,000 actually represents 44.44% of the total sales revenue. So if we take 69.5 times 44.4, we get 30.89%. And if you do that same calculation for product B, you get 32.67. The 30.89% added to the 32.67% gives you also 63.56%. Next item, calculating break-even for units and sales revenue. Here, for the break-even units, we're taking the fixed cost that's been given to us in the problem. And we divide by that weighted average cost per unit that we calculated in part 1 of 19.07. So our break-even units are 1,888 units. To calculate break-even for sales revenue, we take the fixed costs, again, of 36,000, and we divide by the weighted average contribution margin ratio, which we calculated in part 1 as 63.56%. And the result is 56,643.36. Now we want to calculate how many units need to be sold of each product to break even. In this case, we take the 1,888 units that we calculated for the break-even units in total. And for product A, we multiply that by 33.3%. That percent, if you remember, is the 1,000 units for product A divided by the total units of 3,000 gives you the 33.3%. So product A, we need to sell 629 units. For product B, it's 1,888 units times 66.7%. That is 2,000 units divided by 3,000. And that gives us, for product B, we need to sell 1,259. Now let's calculate the total sales necessary for the company to make a profit of $65,000. So here what we do, we take the fixed cost plus the target profit, and we divide by the weighted average contribution margin ratio that we calculated in part 1. That gives us $158,916.08. That's what we have to have in sales in order to make a target profit of $65,000. Next, we want to calculate the revenue generated from each product if the company earns that target net profit of $65,000. So for product A, we're looking at $158,916.08. We're multiplying that by 44.44%. That is that ratio when we take the sales revenue of $40,000 divided by the total sales revenue of $90,000. That's where we get that number. And so that, the $158,916.08 times 44.44%, we get $70,629.37. Now product B is $50,000 of the total of $90,000 revenue. That's the sales mix. And so we take that percentage of 55.56%, multiplying it by the sales necessary that we just calculated of 158,916.08. And product B has to contribute 88,286.71. Now what we want to do is calculate the degree of operating leverage. This takes the contribution margin for all products, so that's $57,200, and we divide by the net operating income, and we calculate this by taking the $57,200 of contribution margin minus the $36,000 in fixed costs. And when we do that calculation, what we get is a number of 2.70. I've put some notes over on the side of the screen there to give you a little bit more grounding in what the degree of operating leverage means. So basically, when the degree of operating leverage goes up, it means our fixed costs are going up. So the company must maintain a certain number of sales in order to cover those fixed costs. But each sale above that level earns you more profit. As the degree of operating leverage goes down, it means you are reducing your fixed costs. But each sale has a smaller increment effect on profit. I hope this helps to understand how to do this and do these calculations with multiple products. And if you have any questions at all about anything covered in this example, please leave your questions below and I'd be happy to respond to you. Thanks so much, and I'll see you on another video.